we go. Standard form is going to look like this. Y equals ax squared plus bx plus c. Okay, and I know you've all seen that before. You've worked with this one a little bit in Algebra 1. We've worked with it a little bit this year. But this is our standard form. Okay, the thing I need you to remember with standard form is there's a new equation that's your like starting point. And if you forget this equation, you can't find anything. Okay, so you have to remember, you're going to memorize. You want to know this equation, okay? The equation is for your axis of symmetry. Okay, if we want to find the axis of symmetry with this, because this is not vertex form, right? In vertex form, we could find the vertex, and then we knew our axis of symmetry from that. This is not vertex form. This is standard form. So you can't just look at it and go, oh, my vertex is fill in the blank. Instead, we have to start with the axis of symmetry. And here's the equation for that. We're going to say x equals a negative b over 2a, okay? This is super important. Make sure you memorize it. It's not a tough one, right? The opposite of b, and then divide by 2 times a. And we're talking about b and a, okay? So in that standard form, you're going to take the opposite of the b value and divide by 2 times the a value. Okay, so that's to find the axis of symmetry. But then from there, you'll find the vertex. Okay, and the way we find the vertex is we take that x value, that negative b over 2a, will be the x value of our vertex, just like it was in vertex form, right? We had the vertex, and then we could find the axis of symmetry. Now we have the axis of symmetry. So if you're thinking about a graph, right? If this is my axis of symmetry, my vertex is somewhere on that dotted line. So that's the x value of my vertex, okay? So we take this, negative b over 2a, and then we plug it into the function to get our y value, okay? Which looks a little funny, but I think once I show you what we're doing with that, you'll know what I'm talking about. So that's axis of symmetry and vertex. And then the last thing is just your Y-intercept. Okay. Do you remember in vertex form how we found the Y-intercept? We plugged in 0. Okay, now let's think about that. If I plug in 0 in this standard form, this goes away and this goes away. So what is your axis of, or what is your Y-intercept always? C. Okay. So your Y-intercept will always be 0, C. Okay, whatever your C value is up here will be the Y-intercept for that graph. Okay, and then just a quick reminder. If your A value is greater than 0, what is your parabola going to look like? If your A value is positive, how does your graph open? It's going to open up, right? If A is positive, it's going to open up. If your A value is negative, it's going to open down. Okay, so that doesn't change. Still going to be very similar in terms of that. Okay. You ready to try it? I feel like my grouchy attitude this morning just kind of put you guys in like even quieter of a funk. I'm sorry. All right, here it is. So if this is our setup, notice the order is different, right? They start you with the axis of symmetry because that's what you have to find first. So to find the axis of symmetry, remember this is x equals negative b over 2a. What is a negative b value right now? Negative 2. So your a value, right? This is a, so a is 1. Your b value is 2, and your c value is 3, okay? So if I'm doing negative b, that's a negative 2 over 2 times what? What's your a value? 1, okay? That means my axis of symmetry is x equals, what does that simplify to? -1, right? So you get x equals -1. That's where this number comes from. Okay, so graph that. X equals -1 is a vertical line at -1. That means my vertex has an x value of -1. How do we find our y value? Plug in -1, right? If we know it's x equals -1, then plug that in for x. So we're going to take this and we're going to plug it in here, oops, and there, okay? So it's going to be y equals, parentheses matter, right? -1 squared plus 2 times -1 plus 3. So our y value of our vertex is going to be 1 minus 2 plus 3. So your y value, what is 1 minus 2 plus 3? 2. So your vertex is going to be the point -1, 2. Okay, so -1, 2, that goes right here. Just looking at the equation, can you tell me what direction this is going to open? Y equals x squared plus 2x plus 3. It's going to open up. Your a value is 1, right? It's still the same a value. So what you're going to do then, well, before I even talk you through that, what's your y-intercept?
3.
It's 3. It's always this number, okay? Your y-intercept is always your c value. So 0, 3 is your y-intercept, 1, 2, 3. So yes, your a term was 1. You could have gone up 1 over 1, up 1 over 1 for both of them, but you also could find your y-intercept on that. So reflect it, and then that's your graph. Okay. Can you tell me the minimum of this graph?
2.
It's 2. It's still the same as it was before. It's the y value of your vertex. What's the domain? All real numbers. And then what's the range? Y is less than or equal to or greater than or equal to? Greater than or equal to. Your y value is going to be greater than or equal to, and that's just your minimum number, right? So your y value is always above that 2 for that one. Yeah.
Why did you go 2 up and then plot back?
Why did I go 2 up?
Yeah, so from the x-axis you went 2 up. Or it's not.
For
what's your
this point?
Yeah.
That's my vertex.
Okay.
-1, 2. So I just plotted -1, 2 as my vertex.
Okay.
Do you see how I got my vertex?
Yeah.
Yeah.
Plug in -1.
Yes. Yep. Questions on that? Okay. Do you want to try this one or you want to do this one together and try the next one? It's up to you. What do you need? Together and then try the third one? Okay, let's do it. What's the equation for the axis of symmetry? -b over 2a, okay? So here's your numbers. What's your a value? -2. What's your b value?
4.
4. What's your c value? 1. Okay, so that's your a, b, and c every single time, okay? So if we do a -b, right now it's a +4, so the opposite of that is going to be a -4 over 2 times what? -2. Okay, so -4 over -4 is a +1. Okay, so your axis of symmetry is x equals 1. And I cannot tell you how crucial negatives are in this stuff because you make a mistake with a negative and the whole problem goes awry, right? We don't like that. We don't like that at all. So x equals 1, that's going to go here, which means my vertex has what x value? 1. Okay, this will always be the same number. So plug in that 1. It's going to be y equals -2 times 1 squared plus 4 times 1 plus 1. Okay, so we plug that in and evaluate. This is negative 2 times 1, so negative 2 plus 4 plus 1. So 2 plus 1 is 3. Right, so that number is the y value of your vertex. Okay, so plot that, 1, 3. That goes here. How do you find the y-intercept? It's your c. So go back up here, look at your c value. So the point 0, 1 is your c value, 0, 1, and then reflect it. Does it make sense that this graph is opening down? Why? Because that negative 2, your a value is negative, so it should be opening down, okay? Okay, so what's your maximum? It's the 3. This number, right, is always your maximum. It's the y value of your vertex. What's the domain? All real numbers. And then your range should be y is less than or equal to or greater than or equal to? Less than or equal to. And it's just that same value again, the 3. Okay? Do you like this one or vertex form better?
This one.
I think this one's a little bit easier. I don't know. Okay, you try number 3. Give it a go. I'll come around. All right, are we close? I'm gonna start plugging some things in up here. So axis of symmetry, x equals negative b over 2a. So like I said, if this is a negative 12, right, if it's minus 12, we treat that like a negative. That means the opposite of that is going to be a positive 12 over 2 times your a value, which is 3. So 12 over 6 is going to be 2. So your axis of symmetry is x equals 2. Okay, and then we plug that 2 in to figure out what our y value is. So 3 times 2 squared minus 12 times 2 plus 6. So that's 4 times 3 is 12 minus 24 plus 6. So 12 minus 24. That's not 12 minus 30, right? Be careful with that. 12 minus 24, you just go left to right with plus and minus. So negative 12 plus 6 is a negative 6. What'd you get for the x-intercept? Sorry, y-intercept. Did I say x? It's always that c value, right? So 0, 6. Okay, so 2, 1, 2, 3, 4, 5, 6. So 2, negative 6 would be there. And then your y-intercept is 0, 6. So 1, 2, 3, 4, 5, 6. That's way over here. And if you reflect that, that's that one. Can you tell me where the point in between those points would fall? How do you get one more point on your graph here? 2 more points on your graph. Yeah, you take that 3, your a value, right? Up 3 over 1 and up 3 over 1. So your u is pretty narrow like that. What's your minimum? What's the low point of your graph?
2.
Not 2, the negative 6, right? We go with the y value. So negative 6 is your minimum. Your domain would be all real numbers. And then your range would be y is greater than or equal to that negative 6. Okay, yeah.
So for minimum and maximum, do you always use the y value?
Yep. This is always the y value of your vertex for minimum and maximum.
Right, and then if you wanted another point, use the slope.
Use the slope, or you could plug in a different number. Like if I had plugged in the number 1, right, that would give me whatever is on that line for my y value then. So you could plug in another number, but this a value is always super helpful just for your first move.
And you only use it once?
One time. You can only use it once. Yep. Okay, last thing. It says graph the parabola with this vertex and y-intercept. So if my vertex, well, you try that. Your vertex is -3, 2, and you have a y-intercept of 3. Try plotting that. Put your axis of symmetry in too, okay? I always want to see where your axis of symmetry falls. A vertex of -3, 2, a y-intercept of 3. What is that going to look like? Okay, so if we go -3, 2, there's your vertex, right? So where's your axis of symmetry?
-3.
At -3. X equals -3. That's this line. Okay, so make sure you draw that in. And then with a y-intercept of 3, 1, 2, 3 would put us there. So where is another point on this graph? -6, 3, right? So if we went 3 to the right, go 3 to the left, and you get another point there. So your graph, this is a pretty wide parabola, right? It's going to open up something like that, and that's all we're looking for there. Questions on that? Yeah.
So since there's no A in the question, we don't have to graph that.
Right. Yep. Just graph what you know. We know the vertex, we know a y-intercept, and then reflect it, right? You can always reflect a point on one side to the other side of your axis of symmetry. Any other questions? All right, that's standard form.